all. Welcome to another high-powered episode of the High Voltage Live Show. I'm your host, Willie Snyder with NEC Code, coming to you live from the Mile City, joined by my awesome co-host with the King James Stall Cup over there in Longhorn Country, over there in the old Big Sky Country, Texas, representing the Stall Cup Electrical Education. And we already got Mr. E popping in, Electrical Wizardry in the house. What's up, David?
Hey, Mr. Englehart.
Thanks for joining us. Appreciate it. And like I say, I really thank everyone so much for all the participation. My myth of the week just crushed. And I say my myth of the week, but this is actually probably King James's myth of the week this week. But and then look who already is kind of trying to swoop in and claim his title.
I'll tell you, I'm not all here tonight. So I've had a long last night and a long day today, and there's some of saw me post early this morning, and there's on one of the groups arguing stuff, and I just said, hey, y'all have at it. I said, I don't have time for this morning. I had to go to the hospital, and my son was having problems, and we're really worried. I mean, Tuesday they did a CAT scan on his whole body and everything, and then they took him in Thursday, and they did something down his throat, shoved something down a tube, and we're checking stuff. Then they went up his rear end and checking up through there and everything, cameras. They were really trying to figure out, he's never put on any weight at all, and he eats like a pig, but I just thought, he just has one hell of a metabolism is what I was thinking.
Right.
But then on the weekend, he started peeing blood and pooping blood, and where I got to get his ass in the doctor, and anyway, he had for all the people that sent me messages, thank you, I appreciate that. But his appendix, I never heard of this before. I've had my appendix removed. I had appendicitis when I was younger, but he had something, the tube or something from the appendicitis. He has a large tube. I mean, it's like a lot bigger than it's supposed to be. Well, anyway, because of that, it his whole life since he's been born, it's been leaking, and it's caused a chemical imbalance. And we used to have problems with him in school for his attention span. Well, the doctor said that was part of it, and it causes mood swings and stuff, which he has. I just thought he's unhappy, but now we know why. And so they're going to treat him with some medicine stuff and give him about a month and just so much to get the tube swelling down. But then they're going to look, and I have a feeling they're just going to go in and remove it. But he said, doctor told me, he goes, once, he's 28. He said, once we fix this, he said, within, the first year, he said, don't be surprised he puts on 15, 20 pounds. He goes, he said, it's going to make that big of a difference. And and of course, nothing against his mom, but he didn't really want his mom there. He wanted me there the whole time. He had his wife there, but he told her, I want Dad here. So I've been spending all my time at the hospital and stuff. And I put on this that this show was in January. My mind's just, I know it's February, but I put January 15th or whatever the hell the day is. And somebody made a comment, they were making fun of me. I said, I'm sorry, brother. I said, my son's in the hospital, and he was, I apologize, and I said, I appreciate it, and just left it at that. Yeah. But that's what I was doing all day. So if I see a little out of it today, y'all know why, because I ain't had any sleep.
I might have blown a little bit of the dog whistle earlier this week. It got the old dogs sicking on us, but like I say, It's pretty funny. I think it's hilarious. And Daniel. Oh man, looks like you and King James are walking the walk of shame with picking the Chiefs for the Super
I
Bowl.
ain't walking it. I'm glad they got beat. I
Yeah,
didn't like
that
either
was
one
your
of the
pick
teams,
though.
so
I picked the Eagles. You guys picked the Chiefs.
I
So
really thought the NFL would have the rest probably do something to get Kansas City 3 in a row. That's why I picked them.
yeah,
I just really thought that. but
could have been.
but Philadelphia beat them so bad they couldn't do anything.
Yeah, true. But
That's sort of like Trump winning the election. He won by so much he couldn't cheat to beat him anyway.
yeah, I mean that the whole thing is just it's it's I'm ready for everything to just quiet down. You know what I mean? It's so crazy. Like
Bring
when you
it
point
down.
out some of these, you point out some of these double standards. You know, and it's just
Well,
it's
like
ridiculous.
one of the guys, and all I did was make a response. I said first and foremost, I was tagged on the thread, and I gave my opinion because, Dad had been doing it. It's funny because I talked to him today, matter of fact, because it's not hospital, and I was with that. I said, "Hey, when did you start Playboy Publishing?" He goes, "Well, actually," he goes, "I think I started it in 1972, but it was started as a publishing company because he played music and he was making records and stuff. And back in that time period, I mean, I learned a lot about things today. So back then when you would apply to get publishing, that included print, audio, everything. Anything to do with publishing, it was all included under one umbrella back then. And
Right.
he was he said I started in 72. He goes, but when we started, he did his first publication uh, that he was selling on his own before American Tech took it over. He said it was 1978. So I explained, my dad started in 1978, and it had been probably 3-4 years before he was going around the country. And I said, and Mike was going to his classes. I said, so there's no way, if Dad ain't been doing it 50 years, there's no way in hell he's been doing it 50 years, because I know when
Yeah.
he was coming to his classes and stuff. And we were talking about it. The one that was a pretty big author back in that time, right before Dad, was Joe McPartland. And if you go back and look at the American Electrician's Handbook, I think it's what it's called. McGraw-Hill puts it out. That's Joe McPartland. His name's still on it. And Joe McPartland is the one that invited Dad down to New York, and he introduced Dad as the next great electrical instructor in the industry. And Joe McPartland was the one that was, it was years and years later, that was going to do the Top Gun and have some of the top experts compete against each other. And they were setting it up, and Mike was going to be a part of it, but he wanted to MC it. He didn't want to be in, against other ones. So he dropped out, and then another one dropped out, and Joe McPartland. It was actually McGraw-Hill that was going to put it on. And then
Wow.
Joe McPartland just said the hell with it, and they just dropped it at that point. But that's how the Top Gun term got started, was back then when with McGraw-Hill and Joe McPartland. So I'll tell you, it's
Yeah, and
always
it was cool. Like going back, and it was kind of cool going back and looking at all that stuff. I mean, I
well,
didn't even start the trade until the '90s.
yeah, and you got. I'm just fortunate because my dad, he's been doing it forever, and you can go back and ask him things, and he tells you this happened, this happened. I mean, he was involved. I mean, of course he was on all different types of co-making panels and standards and everything, and um, a lot of people don't know this. He was part of the UL Electrical Council and also the IEEE Electrical Council, and he's got 2 awards for his outstanding achievement and service from him even. So, and then he won, I think it's called the Howison Award with IAI as top inspector in the country, and all kinds of other awards. I mean, he's got so many. I think he's got like 70 awards. I mean, it's unbelievable the career he's had. So, if he sticks around that long, which I hope he does, but I hope he's around in 2028, because I'm going to take right at the 1st of January, and I'm going to have a big write up for him being in the industry for 50 years with his publications and everything. And I'm going to tell about it. I'm actually going to grab all his different awards, and I'm going to do a write up of all the awards and stuff he's received through the years as far as contributions to the electrical industry. So I figured that's the least I could do. I can't hear you, Bill. Can't hear you.
Oh, sorry. Go. I was coughing a little bit. I didn't want everybody to hear that.
No worries.
So yeah, it was pretty awesome that I do the Nat King Code podcast, and I threw your dad's explanation of 110.26a on there, and that was awesome, man. I mean, he goes through it so thoroughly, and it's so effortless for him, you know. And,
well, you think about it, that when they started making all those changes, really, because, and I'll give everybody a little history lesson, but if you go and look at OSHA, you're going to see 2 dates. You're going to see March the 15th, 1972, and April 16th, 1981. Okay? And when you go look at those dates, anything that was installed before March 15th, 1972 by OSHA federal law, it's automatically grandfathered in. Then they had, in between that time from March 15th, 1972 to April 16th, 1981, basically they said if you come in and did 50% more changes within your plant, you had to bring it up to the current code that was out at that time. And then after 81, everything went to current code, anything you installed. That was new. But they still kept in there, if you come in and do a facility and you're changing out 50% or more, then you got to do the whole thing. So,
right. Yeah, and that was kind of one of the things that, I was kind of just questioning, and when I started looking at like the public inputs and stuff, you didn't see too many different guys, before that. So
no, and that's. Did you turn something that's causing a backfeed? I'm getting a backfeed for whatever happened. But anyway, when Dad, all of that was happening, Dad was actually on the panels and stuff when they were making all the changes and doing everything. And that's why you saw in the National Electrical Code, everything's 3 years, but at one time. And that was 1971 to 1975. That's where you get those dates from right there, March 15th, 1972, that 4-year jump. Well, what they did, they come in and they brought in and started really hammering down in the NEC, putting all this commercial and industrial in, and then it's expanded from that point on. And when Dad's giving insight, you'll hear him sometimes, he'll even go back to when it started and tell you why they did what they did, and you remember we had him on the podcast, and we were talking, he was doing this grounding thing, and I've heard a lot of stuff because I've been to a lot of classes and stuff when I was growing up, and he was talking about table. At that time, it was table 250-94, but now it's 250.66. But he said he went in and he basically gave us the multiplier from where they'd take the overcurrent devices, put the multiplier on it in order to get the circular mill to tell you how they size the conductors in that table. And I was like, you got to freaking be kidding me. And he's going, oh, yeah. He goes, just go ahead and run those calculations. You'll see that's how they size them. He said, go look at Chapter 9, Table 8, where they got the circular mill. You'll see that's how they got those size conductors. I was like, wow, that kind of knowledge right there is from somebody that was actually there when it all took place. And if he's telling you that the code making panel stated that you have to run a number 4, you can't go smaller than that, that's the size they want there, that was the intent. And then you're going to argue with a guy that's telling you what the multiplier and stuff was. I mean, I don't know what to tell you, you know.
Yeah, and those were actually classified as made electrodes. And he kind of walked us through all the made electrodes, and that was the first time I ever heard the term made electrode before. But your made electrode's going to be like your ground rod, your U for ground, and your ground ring are all considered made electrodes. So,
yeah, and he even went through and explained
why
they got rid of it.
Documentation on all that, so it's all been documented. And everything. So,
well,
if people want to misinterpret the code, that's up to them.
The thing is, I don't keep all the documentation all the way back to the 70s and 80s. I mean, if I kept everything when they were doing that, I mean, you're looking 92. I mean, you're looking 30 years. I mean, I at least 30 years. So you're going back 30 years of keeping documentation. I mean, I'm sure you could go through the files and maybe get some of the film and stuff they have and go search it at NFPA if you really wanted it, you know. But, you know, what I say to that, you know, when Dad's telling somebody this, he ain't gaining anything from it. I mean, he's telling you what happened, you know, and he has no reason to lie. And he's explaining the reasoning behind what they did. And I thought it was interesting him explaining why they got rid of the term made electrodes in the first place and then giving the multipliers and everything that they did. So it was really, really interesting. You know, that's a lot of knowledge in that brain.
That's exactly what we said. The code making panel 5 doesn't agree with the substantiation from.
Well, let me state something on that. Yes, he doesn't agree, and they are wrong. And you got members on there that don't know the reason something was done. I'm gonna give an example of this. You can go back and look, and you'll see at this time when they put Dad in as chairman of code making panel 14. They didn't even allow special experts on the committees. But code making panel 14 was so bad and messed up. And this dealt with a lot of the hazardous and all of that. So Dad come in and go look, you'll see all these new members on there and everything. Dad got new members and everybody on there that knew what they were doing. Okay. And I'll tell you, a lot of people that get on these panels and stuff, they're just added on there by an organization, or they're added on there by a manufacturer or something like that. So like you could be with the International Association of Electrical Inspectors, and you could have been added to code making panel 14, but you really didn't have any type of real experience dealing with hazardous locations, but you could have got added on there. And trust me, I've been at the code making panels, and I've even heard Dad. I remember we were eating dinner one night. One of the guys, Dad they were talking about something, and he told Dad, he goes, I can't vote for that. He said, I've been instructed to vote this way. And I heard it with my own ears. I was like, wow. And so a lot of them are instructed to vote a certain way. And they're on that panel, and it's a company, organization, or something that's telling them how to vote. And that happens all the time. And what I'm trying to say is there's a lot of people who are on certain co-making panels and things. They're not experts to be on that type of panel, you know, and they might be strong in something else, but they're not as strong over here. And they're in there voting on stuff they really don't know. Well, that's how code making panel 14 got screwed up so bad. And then they had Dad come in, and you can go look, you'll see when he took over that panel and they added all these new members. And then you go look at that article 500, 1, 2, 3, 4, so on, and you'll see that's when you'll see all them changes that were made in that chapter 5. So, and that's a fact. All you got to do is just go look. So, you know, and I'll give one more example. You know, and you can go verify this. I mean, it's there. Just go grab one of our previous. So show the proof. I mean.
Yeah, we already showed the proof, so whatever.
Yeah, I already showed him where he was on CodeMake panel 14. The new members were at it, and he just forget he went on something else, deflect.
All right, well, let's
hold on one more.
Okay.
Another good example of this is if you go look at our design book before they made the changes to Article 250, go look at that design book and you'll see it's almost laid out exactly like that design book. And there were members that come up and they literally said, we used your design book to help us lay that out because it's laid out general and all this. And like, say, if you're looking at a general requirement for it being effective, continuous, and permanent, okay, that used to be in 250-51. Well, we had it up at the front of our chapter because there was a general requirement of what that path needed to be. And now if you go look, where's it at? It's in 250.4. It's at the front of Article 250. And you'll see that we would cover the grounding electrodes and the installation of them. Then we get into bonding and things like that. We took it all the way through, and that's pretty much how they laid the new Article 250 out.
Yeah, so, the supply side bonding jumper, and the equipment side.
Yeah, matter of fact, you know Mark Odie, right? Or you know Mark Odie.
Yeah.
Mark Odie, I was teaching a grounding class and NFPA, and he was there. We were actually teaching together, and I was teaching it, and I said, you know, when I look at grounding, I do it in two parts. You got the supply side and you got the load side. And then I went through and explained how the tables were used and everything. And I had to get him on here one time, but he said, he goes, you know what? He goes, that makes a lot of sense. I'm going to start teaching it that way.
The design book's on the LMS system, Jeremy. You could go.
Yep, it's on there.
You're already in there. So, let's check out the meme.
All right. Let me get over here. There we go. That's so true.
I was talking to I stole that from Trader Bill, so right on, thanks Trader.
That's funny. It starts with a 2. That's so true.
One of the apprentices kid was like 18, and he says, how do you know that your girl was the one, you know? And it was funny because I didn't hear him right, and I thought he said, how do you know your girl was a woman, you know? And I'm just like, what? You know, and so it was funny. I basically gave him that look, like that was the exact look, like, excuse me, you know? And it was just funny because I was thinking it was kind of one of those millennial things, you know? And
that's funny.
You know, David likes it, so yeah, that's pretty funny, David.
I like that. And that's funny when it starts with a 2. That's so true. And this is the perfect time to do it because you couldn't do it with a 1 for a long time.
Yeah, I remember one time I was taking my son to school, and he says, he asked me, hey, what was it like in 1900s? You know, and then that's when I realized, you know, he's just barely right there. He was born in 99, so, you know what I mean? Like, like he's right under that, but it's still kind of that same thing. So.
Yeah, my youngest daughter was in 99, my son's 95, and my oldest daughter is 94. So
okay, cool. We all got kids about the same.
Oh, yeah.
But yeah. So then we'll roll the myth of the week.
All right.
It's time for Myth of the Week.
All right, so I appreciate you putting together the Myth of the Week, James.
No
One
worries.
thing I noticed about the Myth of the Week is like I always come through a lot of guys on the job site or guys I work with, and I'll ask them like, hey, what's kind of myths you hear and da 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 da, and then they'll tell me, and then I'll be like, ooh, that's a good one. I have to cover. And so this one, I actually was asking James, like what's one of the myths that just drives you crazy? And man, this is a good one, So on this nameplate here, they actually give you a minimum value of motor start. So if you look at 422, or it's 44022A, it says that the motor, basically the code says all that has to happen is the motor has to start. So they don't technically give you a minimum, and yeah, David's 100% correct there. This is sized off 240.4G for your overcurrent device and your conductor. So that's giving you 240.4G is giving you permission to run whatever the minimum ampacity is on this nameplate, which on here it's 20 amps, which is your the arrows are pointing to that load, which is roughly about 16.4 amps, I think. And then once you do your 125%, it comes around 20 point something. Well, if it's 20.0, you could actually use 14. You could use 14 gauge THHN /THWN. Now, if you use NM cable, you're gonna have to go to number 12. And that's your motor starting minimum. So yeah, you're right, Weed Man. And so what this question was on the myth was where does that minimum come from? Does that come from the National Electric Code, or how does the manufacturer get that value? And so if you look at that, and David makes a good point too, because if you have that 11014C1, then you're going to need to go off the 70 degrees C column, and that's if your terminals are not 75 degrees C or they're unknown. Then you're going to have to go off that. And, so that's kind of where, Weedman makes a good point that 175% is where the NEC gives that minimum to the manufacturer. And what happens is the code tells you the motor has to start. So you could go lower than that 175%, but as long as the motor starts. But that 175% is your minimum motor start. They just give you that as a starting point. And then your maximum is not to exceed 225%. So I know you're chomping at the bit to tear this up, James. I just wanted to kind of give my initial introduction, and hopefully I didn't miss anything that
No worries. Well, there's been this argument, and just like you threw
here's
up,
actually the argument right here.
yes,
Because if you can go below 175%, and it's not a violation.
Well,
the code tells you the motor has to start. That would be the only violation.
Well, there was let me explain what happened. So I was on NEC Live, and I was doing a motor problem, and then I did an AC unit, and I did welders. I did all kinds of stuff just off the top of my head, and was given step by step, and literally pretty much just doing it off memory and giving the values and everything, and doing it with the sections tables and everything. And I said the minimum size. Well, after that happened, a bunch of people come out and said, there's no such thing as guys at ECD did. They come out and said, there's no such thing as a minimum. And I said, yeah, there is. And they said that terminology is not used in the industry. And I said, well, have you ever taken looking at an AC unit and look where it talks about the minimum and maximum size HACR breaker rating? And they said, well, that's on the nameplate. That doesn't count. And I said, well, sure it does. Where do you think they got it from? They had to come up with it somewhere. So what I decided to do is prove my point. So if you go over and you look at OSHA 1910 and you look at 1910.78 and just start it off.
Yeah, that's a good point, David. And actually, the code gives you guidance.
That's exactly right.
If it trips, then you can go up to the next standard size.
Sure, and I'm going to show you something, and I'm going to prove this fact. When I started doing this, looking at the calculations, I realized I didn't at first, but I was like, this is a new AC unit because I've seen it on some of the AC units, and I'm going to show you what they're doing now on those nameplates, and I'm going to prove this point. So when you look at the application, it says, this section shall apply only when the term your NRTL, your NERDL, National Recognized Testing Laboratory, is used in other sections of this part. So then they tell you what it means, and it's an organization which is recognized by OSHA in accordance with Appendix A of this section, in which tests for safety. That's the main thing. They're testing for safety when they do this. And lists or labels or accepts equipment or materials which meet the following criteria. And then it tells you for each specified item of equipment or material to be listed, labeled, or accepted by a NERDL, has the capability, and this includes the proper testing equipment and facilities, trained staff, written testing procedures, and calibration and quality control programs to perform it, and testing and examining of equipment materials. Now, this is what is so interesting, because it says testing and examining of equipment and materials, look at this, for workplace safety purposes to determine conformance, now listen to this, with appropriate test standards. Okay, now we're going to get to test standards here in just a little bit. Then it says experimental. No, the listed label.
Yeah. What's that based off of? The NERDL, right?
Yes, that's off 110.3B, and I can break that down in a little bit. Let me get through this first. It says experimental testing and examining of equipment and materials for workplace safety purposes to determine conformance with appropriate test standards or performance in a specified manner. Okay, so they're giving us criteria here in order for somebody to list and label that equipment. They're telling you it has to be in conformance with appropriate test standards. We all agree with that so far. Okay? Yeah. Now, from here, this is where you come into the test standards. Okay? Anybody watching this podcast, I'll tell you, you need to be familiar with 1910.7C. Okay? When it comes to listing and labeling, because this is what they're going to ask for. It says the appropriate test standard, as referred to in B1 and 2, which we just read. It says is a document which specifies the safety requirements for specific equipment or class of equipment, and is, now let's see what it says. It's recognized in the United States as a safety standard providing an adequate level of safety. Now, this next part is this is the most important part. Compatible with and maintain current with periodic provisions of applicable national codes and installation standards. Okay, now, they're telling you they're going to look at the National Electrical Code, 70, anything that's going to form the tripod or any other standards. So you could be doing something hazardous and you may be looking at the gas code or something that's compatible with that piece of equipment. All right.
Is there anywhere where that standard only applies to the workplace?
Well, anything you do is the workplace. I mean, I could go out and work on residential. I mean, I'll ask it this way. Let's say I go out and I work on something at a residential, and I could actually take and lock and tag that out before I even worked on it. Do you have to follow those rules?
Oh, yeah.
Sure. OSHA requires that. Okay, that's where it all got started, was OSHA. And I want people to pay attention to what I'm saying here. So what the argument, like Jeremy's arguing right now, well, if OSHA didn't apply, then why did we apply lockout and tagout to start with? Because it wasn't in 70E, it wasn't in any other standards at that point. So where were they getting it from? They were getting it from OSHA. They applied it as a national standard. And, you can't, and you've heard me say this many times, you can't pick and choose. You have to use the codes and standards as a whole. Okay? But just to prove that point a little more, let's see what's required in order to have this test standard and who's involved. So it says, developed by a standards developing organization under a method, providing for input and consideration of views. And let's see what it says. Yes, it would. That would be workplace. Anytime you're doing maintenance or anything, it's workplace. Okay? Sure. And it says for input and consideration of views of, let's see what they say, different industry groups, experts, users, consumers, governmental authorities, and others having a broad experience in the safety field involved. Then it says, in lieu of the first three things I read, the standard is currently designated as an ANSI standard, safety designated product standard, or an American Society for Testing and Materials, which is your ASTM test standard used for evaluation of products or materials. So in other words, in order to even have this standard to be considered ANSI or ASTM, you've got to make sure that equipment is kept up and maintained current with periodic provisions of applicable national codes and installation standards. Okay? This isn't debatable. And, when, they say it doesn't.
You better not work on your own house there, Jeremy. I'll have to tell the union you're stealing work from them.
Well, let me put it this way. Because I've done a lot of special expert testimony. And let's say you go out there and you work on something, not even your house, just say somebody else's house. You think nobody's there and you take the panel board cover off and you go off and work on something and somebody walks in there and touches that, gets electrocuted. Who do you think's responsible? Because now all of a sudden that's going to be a workplace.
Yeah.
You can't get around that.
Yeah, OSHA can cite you, dude.
Sure they can. They're not limited. OSHA can go anywhere. And, it's very clear right here that this is for workplace. And just because you're residential, say somebody goes out there and works on your AC unit, and they take the cover off and everything, just leave it all open, everything's running, they run off, go to lunch, whatever. Some kid's out there playing, gets up in it and gets electrocuted. Is that still considered in the workplace? Sure, because nobody should be in there. And
you better have a permit too.
And let me state it this way also. And this is another good example. This is why facilities go in and they train their personnel and they put up barricades and everything and tell them what those barricades are, because that's a workplace facility. Now, a homeowner's not trained on that. So there's at no time you should leave anything open to where they would have exposure and access where somebody could get hurt.
True.
Okay.
100%.
And these are things that I'm saying. It's like 70E. I'll give you another good example. People have asked me.
Yeah, 70E applies to your own house.
70E applies to everything. And, I've had people ask, well, what industries it apply to? Anybody that has access, it applies to. I'll give you a good example. I was doing a class for BPI, which is a Building Professional Institute, and we have all the inspectors from Texas that would come to it. and they asked me to do an OSHA class. And so I did those class, and I was explaining to the inspectors, if you go inside that barricaded area and there's a potential for the arc flash, and you know where that arc flash boundary comes out to, if you go inside that arc flash boundary, guess what? You have to suit up.
Right.
Because you have exposure. If you notice, 70E does not call out any particular people. It applies to everybody. So
Right.
you have to know what you're doing. So if I go work on a residential and say that I can work on this unit or whatever I'm doing, and I'm going to go out there, just say I'm doing maintenance on a stove, a refrigerator. I don't care what it is. That guy that's going out there to do that testing and everything has to be trained to know to apply lockout, tag out, and verify that everything's de-energized. Okay?
Yeah,
Because the first rule of thumb is you de-energize and lock out and tag out if you can. If not, there has to be some reason, and we've got reasons that are set over in Article 130, and we lay those out. And if you don't meet those reasons there, then you need to lock and tag it out.
I mean, what are you doing really, like when you're working on your own house, you're acting as the contractor. So,
Yeah. You're taking it into your own hands. And I'll give you an example. Let's say that you work on something that you know that's hazardous like that, okay? And say you have a life insurance policy and you get killed get electrocuted working on something that you didn't know how to work on. You think the insurance policy ain't going to fight having to pay that?
Yeah.
I'm just telling you, I've dealt with a lot of things like this, and you have to.
And what are they going to use? They're going to use the OSHA standard.
Mm-hmm. Guarantee you they are. And that's why I wanted to bring this up before I got into it. So then
Right.
I want to point this out to everybody. Now, if you go in and look at the 2023 NEC and you look at earlier versions and you're looking at 430.52C1. Now, if I look at 430.52C1, you've heard me say this because in our publications, it's been this way for 30 years, okay? And we've always said minimum size, neck size, and maximum size when you're sizing the circuit breaker. We've had apprenticeships all over the country. IEC used to use our publications. The union actually used our publications in some jurisdictions, and they use a design book. All these years go by, nobody's ever complained. They agreed with it and said, yeah, that makes sense. And we even have a note in there that says, even though you do the minimum size at your starting point, you still go lower if the motor will handle the load and the breaker doesn't. The breaker will hold the motor load and doesn't trip. Okay?
Yeah, and
So,
part of the reason why I wanted to do this too is a lot of guys, like in this case, they'll be like, I want to use a 20 amp on number 12 because they feel comfortable with that or whatever.
well,
That's fine. Code says that's totally fine as long as the motor starts. If the motor doesn't start, then you're permitted to go to that minimum size. And then
sure.
if it still doesn't start, you can go to that maximum size and
Well,
there's no code violation.
The most time when they're getting that's because they're looking at 240.4D when you're dealing with small conductors. That's what they remember.
100%.
Okay? So when you look at that, we used to have 430.52 C1, and then you had exception 1 and exception 2. And exception 1 just allowed you to go up to the next standard size. And that's what it says, the next standard size. That's why we call it the next size. And then you go up to exception 2, then you could go up to a higher percentage, which was your maximum. Okay? Now, when you go over and look at that section now, it's 430.52C1A and B. It's not exceptions anymore. Now that you know that, when they came into the 2023 and you go over and look at 440.22A, they basically moved a lot of the same language over here, and they added an exception 1 and exception 2. The 175% and 225% used to just be in one paragraph. Now you pick it up and you've got the 175 is the main paragraph text. Then you've got an exception 1 that allows you to go up the next standard size, and then you've got the exception 2 if it still won't start to go to the maximum, which is 225%. So when I was looking at this, I knew this because I had talked to an AC manufacturer. It's been about a year and a half ago, I guess, too, something like that. And they had, he told me that when they do the calculation, they just go ahead and go up to the next size as their minimum, but you can still go down below that. So when you look at that picture that you had on there, that was a newer AC unit. So I started looking at this, and I just decided, you know what, I'll just sort of show it and go from there. And I forgot to take that 0.5 off there on the maximum.
I got a good answer to the question in the chat. So how can OSHA prove that Weedman did the work? And it's because a glorified ditch digger is going to be a special expert. It's going to say, this looks like Weedman's work here.
Yeah. Okay, so if you look at that illustration, and we had 15.3 amps for the condenser, the compressor, then condenser, you have 1 amp. So if you take the 15.3 amps at 175%, then add the 1 amp on there, you got 27.78 amps. And if you go look at that nameplate, they had a 30 amp. And then, but if you want to go lower, because if you look at 440.22a, it says you can't exceed the calculated load, so you're going to drop down. So that 27.78 amps, you could put a 25 or 30 amp on there, okay? Right. Then if I go look at step 3 and I apply exception 2, didn't start due to inrush current, then I would take it at 225% with the 1.5, and that's going to give you 35.43 amps. And what's the next size below that? A 35 amp, which was listed on the nameplate. So what I'm trying to point out here is I stated that they follow listing and labeling based on what? National codes and installation standards. That's where I've never said it wasn't.
Yeah.
I've always agreed with that.
I'm just glad Jeremy's learning, that's cool, Jeremy. Come on in here and learn.
But what I'm trying to point out is even on that nameplate, they have minimum, and you could go lower, which would have been a 25 amp. But what they're doing, just to keep from learning, they just say, let's just go up to the next size and put a 30 amp, and then let's do it at 225%. I can't exceed it there. So what they do, they drop down, because you can't exceed the calculated load. Now, what that's doing at this point, it's showing they're following what? The national codes and installation standards. And therefore, it has met the safety requirements that are required. And UL, the listing agencies and everybody have said, yeah, that's the minimum size that we're going to set at, and they actually have it on the nameplate. Now, that's just a fact. That's not even a debate for discussion right now. Because
it sure says minimum on the nameplate, Weedman, so I don't know. It's based off 175%.
Let's go back. Right here, you've got minimum fuse breaker, HACR breaker size, and you got maximum size. Okay? And, they told me that terminology is not used in the industry. Here it is. Yeah. And this is proven a point when you get in and you start looking at OSHA and what their requirements are. Okay? And here is the text right here. And as I was saying, 440.22a, what does it say? A protected device having a rating or setting, and listen to what it says, not exceeding. So you can't exceed it, so you have to drop down, which would have been a 25 amp. That's your starting point. That's the minimum, but you can still go down below that. And then
Yeah, and you could go lower because it says the motor has to start. That's the only requirement the NEC gives you.
yeah, well, look what it says. The motor compressor, branch circuit, short circuit, and ground fault protective device shall be capable of carrying what? The starting current of the motor. So if you go lower and it starts, it carried it, you're fine. But they did have a minimum starting point for you.
Yeah, you could go below 175. Code doesn't,
We're not saying you can't. It says it
Yeah.
right there that you can. But what the argument is the minimum is a starting point. It's like I said, if you look over at table 43052 when you're dealing with motors, in the heading of the table it says maximum, but that's the maximum percentage that they're setting up for that table. It's not, you can't have two maximums. So,
Right.
The industry for 30 years had always said minimum, and instructors all over the country were teaching. I used to teach.
Yeah, you can't have like a minimum maximum and a maximum maximum.
Yeah, I taught for NFPA for 30 years. And I'm out there teaching engineers, everybody, and we go over the motor calculations, and even the NFPA material said minimum. I mean, and then all of a sudden, I guess because I said it, it's wrong all of a sudden. But yet, all these years, everybody's been teaching it that way. And now you got the new groups coming in, and they're telling us, all of us guys before that, we're all a bunch of idiots, and we've been doing it wrong all these years. So,
Yeah.
anyway,
No,
that's my
it's
wrap
pretty
up
funny.
on it.
Like, I'm just glad that Weedman came in here and he's learning. So, yeah, he's really surprised. So, that's cool. That's cool you're learning, Weedman. Appreciate it. That's cool he comes in here and learns. And,
Well,
like I say, it just surprised him. Like, look how surprised he is.
The only thing I want to say
pretty surprising
about it, and I don't care if they don't want to do it, that's fine. Classified however you want. I don't really care. But my whole point is that when they develop those testing procedures and standards and give it an ASTM or to say ASTM because that's what most of them are, and or ASTM, it's one of the two. But whichever one they're going off of, they are looking at the electrical codes and installation standards to determine how they're going to size that. And if they come in and they say, this is a minimum, that's your starting point right here, and they even put it on the nameplate, that's telling me that industry experts and everybody that they have on these committees that help write these test standards agree with it. So
I challenge you, Gopher fan, post up any educator's material that shows it better. That's it. Pretty simple. So any educator that has a diagram that shows the minimum, that's not the minimum, but it's kind of the minimum, but it's not the minimum. It's based on 175%. Because the code gives you that permission to go lower. It says the motor has to start. Bottom line, that gives you the out right there that you can go below the minimum.
That's right. And, like I was saying.
We never said the NEC requires a minimum. We said that it's based off a minimum percentage.
Well, the only thing I want to say is, instructors all over the country, for 30 years have been teaching it that way. Now all of a sudden it's wrong. And that's when I have a problem, because you're doing a disservice to all the other instructors that have been out there teaching it. And you got a few certain guys, they're over ECD, saying, oh, y'all a bunch of dummies, blah, blah, blah. You don't know what you're talking about. Well, you're doing a slap in the face to everybody else, because that's the way they used to teach it too. So, matter of fact, I've seen even tests that do it that way, that ask you for a minimum. I've seen tests that do that.
I think it's a good thing to know, because a lot of guys, I was probably guilty of this too when I went to take my test, way back a million years ago. I was just like, hey, I don't need to do the math. I'll just, put in a 200 amp service. I don't need to do the math. And so next thing you know, I realized I got it wrong, and then I went back and looked, and I did all the calculation, and it came out to 124. And I thought you had to add all kinds of, different calculations, like adjustment factors and everything. Like, I didn't know that you could just do the residential service calc, come up with the answer at 124 and just put 125 amp in. Mm-hmm. And so that's like the kind of naive thing that I kind of want to have these apprentices avoid, is thinking all this, because if you come up with your calculations and it's exact number, then that's going to be the correct answer. And I'll admit that I was probably needed to get educated, kind of like you, Weedman. There's things we all need to learn. And so
well,
you can call me names, whatever you want. That's cool.
Every day I learn something.
Yeah.
I'm always pushing myself, to learn something. It could be something on the NEC. It could be something 70B. It could be on the EECA committee, I'm on. I used to be on 70B, always learning that. Then, I got into learning how to draw illustrations, then laying out books, I always pushing myself to learn something. And I've made tons of mistakes, tons and tons, but I learned from the mistakes, but I'll tell you this, when I first started teaching, I remember my dad gave me a good advice. He said, when you're teaching, he said, if you don't know something, he said, don't bull somebody around. He said, if you don't know, just say, I'm not sure about that. I'll check on it at break. And I had Dad's number, Mark's number, Caligero's. I had all their numbers. And if I didn't know, I'd call somebody. And I'd get the right answer.
So, like, a good example is, like, let's just say you did, like, a 30th anniversary party for whatever, stall cups. Let's just say you did that. What are they going to come out and tell you right away, the minute you're posting it? What's going to come in the comments? Oh, show you the proof, right? So that was the whole point of what I wanted to say is I can't find no proof of any 50th anniversary or anything. And, everyone was hating on me and everything. It's like, whatever, to me, it just seemed kind of weird that you're going to sit there and ask King James for proof on everything, but then, all these other people, they get a free pass because,
there's a double standard there. And, I've got to where I don't care. I'm at a point now, I just argue with them just to laugh at them. But, I know things that when certain people were doing things, and I know Dad started in 78 with publications and stuff, writing them and all that. And I know at least 5 years after, if not longer, that's when Mike was attending his classes. And, it was like Jeremy, he was asking me to show proof about Mike getting on at ECNM. I was there. Mike called Dad and asked Dad to put a good word in for him. And the guy's name that was editor-in-chief there at the time was Joe D-Dad. And Dad put a good word in for him, and he got on to write there. Dad and I were already writing for ECNM at that point and doing all kinds of different articles and things like that. And I think Mike started off, I think he was doing an NEC question or a couple of questions or something when he started. Because at that time, I was doing their calculation articles. And then it was probably about a year and a half, two after that, NFPA started doing a magazine, and we went over there. Dad was actually the editor-in-chief there for the electrical articles and stuff. And I think it was Dad, me, I think Mark wrote there too. But Dad and I were the main ones that were writing the articles for them. When they had the magazine, they did it for about 3 years. And then they decided it was too much trouble and everything. And you had EC&M and them all getting mad at NFPA because they felt like it was hurting themselves, and they just didn't want the conflict, so they closed it down. And then we were.
and like I say,
I can tell you, just go look, and they got their magazines on their website that they did. Go see who was the one writing articles. I mean, it's there.
And
go find. I'm not gonna go search it. I'm telling you, it's there.
The whole reason why I even question this is because if you go through like the public inputs for the National Electric Code, you don't start seeing Mike Holt in there until '84, and you know, like I say, he could have changed 10 company names by then in that period of time. But, you know, the thing is that it's kind of one of those things that, you know, he's a pretty, you know, high up person as far as like highly regarded, highly respected, you know, like he doesn't need to like make up like an extra 10 years. Like there's no reason to do that. Like I didn't understand that, but that's just me. I don't know why you would, you know, fabricate an extra 10 years on your, you know, business or whatever. It's just,
yeah. I mean, you go and you go in there. I think I forget which one it is that you go into their journal, NFPA journal. I think if you go over there, I think that's where it is. You go to NFPA journal and just type in James Stallcup. You'll see the articles. I mean, it ain't hard. I'm not gonna go look it all up and do everything, but the proof is there.
Oh, the burden of proof's on you.
Oh, always. Well, I'm not going to look it up because I got too many. I mean, I'm dealing with too many other things right now. But anyway, ready to get the topic of the week?
Yeah, let's do it.
All right.
I forgot to put a comment in because we were asking if we wanted to do the topic. That's Weedman said,
Okay. Well, this week what we're going to do, actually, you know, I get different messages. People message me and stuff like that, and they said do some grounding. You know, you hadn't done anything on grounding in a while, and I said, okay, yeah. I said, sure. So there were some other things. I think next week I'm going to do something on hazardous because I'm getting some. I've had like 5 comments to do some hazardous, so I'll go in and do some real good hazardous stuff. But anyway, when you go over and you look at 250.64 and you pick up that section, the main thing it's going to state there, it's going to talk about the different type of wiring methods that are permitted that you can utilize for bonding, grounding, and also enclosing your grounding electrode conductors. And then there's going to be like a list that's going to go down underneath that. So you're going to end up picking up like 250.64A. That's going to deal with your aluminum and copper clad aluminum conductors. And then when you pick up B, that's going to deal with your securing and protection against physical damage. And then when you get to C, that's where you get the grounding electrode conductor where it's continuous. And if I'm not mistaken, I'm going off memory here, but I think we have 2 illustrations that we're going to look at when we get to that. And then when you get to D, you're going to deal with your service with multiple disconnecting means enclosures. And then when you look at that, there's going to be a list underneath there that we'll look at. And that's going to deal with your common grounding electrode conductor and taps, your individual grounding electrode conductors, and then it's going to discuss about the common location, and then it's going to talk about the building or structure. Okay. And then the next one you'll get to will be E, and that's where we're going to discuss the enclosures for the grounding electrode conductors. And then the last one is going to be F, and that's where it gets in and it talks about the installation to electrodes. Okay. So when you go in and you look at A, they talk about those aluminum or copper clad aluminum conductors, and they tell you right away if you have one of those type of conductors, there's going to be some restrictions on it. So it's going to tell you it's
Yeah,
not.
so isn't that where it can't be terminated within 18 inches from the earth?
Yes. And what it's
Okay.
going to tell you, it's going to have some restrictions. It's going to tell you the locations it's not permitted to be installed. And what it's going to tell you, it's going to say where it's in direct contact, where you have masonry or the earth. And then, of course, like any of them, it's where it's subject to corrosive conditions. And then it also tells you that those conductors are not permitted to be installed where they're 18 inches, within 18 inches of the earth. And of course, that's naturally where the conductors are installed outside. Now,
Hey, so I
as
have a good one for you.
mhm.
What if the manufacturer came out with a specific design that was able to be installed below 18 inches? Would that manufacturer instructions override the code?
Well, yeah,
Or
the
would the code
manufacturer's
override the man?
instruction, see, I think something's going to happen here. Uh, you, uh, I forget the guy's name, but he's the guy that is over, that's they're looking at for 2029 doing the restructuring of the code and the
Oh,
numbering
that's
and all
that's
that.
Larry Ayers.
Okay. There was a thing that in uh, 110.3B, they come in and they said the NEC overrides the listing manufacturer. Even he made the statement that this can cause problems. And
Yeah, I think I saw that in the public input stage or public comment stage.
yeah, and he's even recognizing the fact because somebody, in other words, if the manufacturer tells you not to do something and you do it and something happens, the manufacturer washes his hands at that point because
True.
you broke the listing and labeling. It doesn't matter. And I'm just, everybody can come in and they can say, oh, no, the NEC overrides it. Well, no, the piece of equipment was designed with the code in mind when they got the listing and labeling. It's a
True.
requirement in order to be a NERDL to get that listing and labeling by OSHA. Period. You have to do it. There's no ifs, ands, or buts behind that. You have to do it. Now,
Yeah, what this
if
comes
that's the
down
case,
to.
and I'm gonna give an example. Let's say, because we've actually been contacted by Linux. My dad, they actually contacted Dad, and he said, just tell them don't put GFCI protection on it. And they said, can we do that? He said, yeah. Work with the test standard, and they say, yeah, it doesn't need GFCI protection. And let's say that they put that in their listing and labeling, and you got an AC unit out there, and the inspector comes in and he says, oh, no, the code making panel made the statement that the NEC overrides it, and therefore we're going to require GFCI protection. You're here in Texas. All of a sudden, it's really, really hot one day. The next thing you know, the breaker trips, and then you have an old person in there, and they die heat exhaustion because they didn't know how to reset or whatever. They're just not all there to know what to do. Now, there's going to be a lawsuit. I'm telling you,
Yeah.
that somebody's going to get sued. So they're going to go to the city. Now, if I'm the city, I'm looking at that and I'm going to say, oh, no. That says right here that the committee made the statement that it overrides it. So we have to do it because we accept that. Then they're going to go to NEC and they're going to say, you stated here that you override this manufacturer's instructions. and this person died because you put that GFCI on there, guess what? They're going to become part of the lawsuit at that point.
Oh man,
Because,
Beadman agrees.
mhm. So
So
if you're looking at that, if I'm an attorney, I'm going to look at that and what was stated there. Now, somebody has to be responsible. Well, the manufacturer say, hey, if they hadn't put GFC on it, that person still be alive.
yeah,
I'm telling
I
you
didn't
how
mean
this goes.
I didn't mean to like bring everybody into a rabbit hole, but I was just showing an example that there's certain ways that the manufacturer can say, like if that's terminated within 18 inches, and they have some kind of method that is going to protect that, from corrosiveness, then that would actually comply with 110.3b.
Sure. Now, the next thing that you get into is this is where you're securing and protecting against physical damage for that grounding electrode. And there's some rules here that the grounding electrode that you're using to connect to the service enclosure to the grounding electrode system. Now, they have certain requirements there they want you to follow, and I'm just going to do it off the top of my head, and you see in the illustration there. But it tells you that those grounding electrode conductors, that they are permitted, that you can install them on or through framing members. Okay, that's the first thing is get in. We don't really get deep into that in that illustration, but I'm just pointing that out. Then it tells you that if you have grounding electrode conductors that are number 4 or larger, they're required to be securely fastened to the service. And grounding electrode conductors not exposed to physical damage, they're not required to have any additional protection. Okay? Then it tells you if you have a number 6 grounding electrode conductor, it's required. You have to run it along the building surface construction, and that's without metal covering, if not exposed to physical damage. Then it tells you rigid metal conduit, RMC, IMC, Schedule 80 PVC, EMT, or a cable armor shall be permitted to be used where the grounding electrode conductor naturally is exposed to what? Physical damage.
Yeah, and that is a really conditional thing. Like, I think the inspector would have to have some kind of like major issue to bring up that. Like, you'd have to have like, it would have to be like wrapped around something that gets turned off and on, or there would have to be some way that it like is next to a chopping block or something. Like, I mean, if you put that in the cracks of your mortar or something, I don't see that being exposed to physical damage.
Sure. And then it goes in, it
real
tells you,
conditional.
it lists all those same protection techniques, and it tells you they're also permitted, and it says, I think what it says, shall be permitted to be used for installing a grounding electrode conductor smaller than number 6. And then they also tell you in there, in most cases where you're using a number 8 grounding electrode conductor, of course, it's naturally required to be installed per table 256-66. And why is the reason that is? Because there's no overcurrent protection device ahead of the service conductors.
True.
Okay? Now, I want to point one other thing out because somebody may ask this, but grounding electrodes and your grounding electrode bonding jumpers, they do not comply with this requirement.
Right.
Okay? So that sort of helps take care of that, and that gets that illustration out of the way. Now,
Right.
the next one you're going to look at, this is C. Now, this is where you get into continuous. We're going to show you 2 different types of illustrations to deal with this. But basically, they're telling you that the grounding electrode conductor is required here to be installed in one continuous length without a splice or joint, except where it's permitted in these following 2 illustrations we're going to talk about. The first one it talks about splicing of the wire type shall be permitted only by irreversible compression type connectors that are listed for the purpose, or you're doing it by exthermal welding process. Okay?
Right.
So when you're looking at this illustration, you can see right here at the bottom of the illustration, we're showing you where you're splicing it down here with an irreversible compression connector here. Okay?
Wow, man, freaking Weed Man's like learning a lot tonight, man. That's pretty cool, man. Dude, thanks for coming by, Weed Man. Yeah, says you sound like a professional, so that's cool.
Oh, okay. Well,
Yeah.
but
Awesome.
that takes care of that one. And then we also took up here, we tell you, and we're showing where you're coming up and you're making these connections up here in this wireway. We also tell you the sections you need to go look at when you're dealing with the tap conductors. Okay? Which we're going to get to in just a little bit. All right? So then you look at the next slide and you'll see this a little bit different. We're showing you where they have a bus bar that's in the wireway and they're making their connections to that up top. And then you'll notice where we're coming down, everything's connecting through the meter base all the way down the panel board. And then we've got our common grounding electrode conductor down here. That's a solid continuous piece. And then you're tapping off of that with your grounding electrode conductors. So, excuse me. When I look at that next part of C, it says, a grounding electrode conductor shall be permitted to be spliced in bus bars if they are located as meter enclosures, etc. Well, if you look at that, that's above the meter, isn't it? Okay, so it's giving me that permission. Then it says when you have bolted, riveted, or welded connections of your structural metal frames or buildings, that they shall be permitted. Then it also says you could have threaded, welded, braced, soldered, or bolted flange connections for your metal water pipe. They also allow that for your connection. Okay, so when you're looking at this illustration, we showed one where it was continuous going up through the top and you're making connections tapping off in the wireway, and then we show one where it's coming up and they got a bus bar up here. Okay.
Yeah, I don't know, man. I think those meters look a little high.
Yeah.
Those meters are probably pretty
10 foot high, baby. Get that ladder out. Now,
there you go.
This next one is where you're going to get in. You're going to look at D1 through D3. And basically what you're going to get into here, this is where you have your common grounding electrode conductor and taps. And let's see what we're doing here. Now, you're going to have your common grounding electrode conductor, and you also have your grounding electrode conductor taps. And they're going to tell you here that they're required to be installed where the service is installed. And I remember doing this a while back. When you want to install and look at 230.4 exception 2. Okay.
Gotcha.
And this is where you get into services and stuff. And what this really is getting into is sometimes they'll come in and you go over and look at 230.40, like if you have an apartment building and their jurisdictions are a little bit different, but you have a location and you're allowed 6 throws of the hand. Some of them will come over 5 foot, 3 foot. I've seen them do 10 foot, and they'll bring another service over there and they consider that another location.
Right.
Okay.
So would there be any reason that you couldn't rely on those lock rings from that meter enclosure to your panel board? Would that be sufficient bonding?
Yeah, for that.
Or do you have to have a wire type?
No, you do that, but we're showing here just the difference in the wire connections of things you can do that you could see out in the field. So
Okay.
we're showing everything here. So
Okay.
and you'll notice we show where, like up in the auxiliary gutter there, we're showing where you're bonding it actually to that auxiliary gutter, and you can see
Gotcha.
where we show it bonded all in and everything. Now,
But that's not technically required per code, right?
Well, it'll all be bonded in because you're going to take the bar and it's going to be bonded straight to the can anyway. Okay?
Right, but you don't technically need a wire type for all that.
No, no. But for this
Right.
purpose, we want to show all the wires and everything and the connections and all of that.
Gotcha.
So then it talks about the common grounding electrode conductor, and it's going to tell you it's required to be sized per what? Table 25066, and it's based on the largest ungrounded phase service entrance conductors. Okay? Then it says the common grounding electrode conductor shall be sized per table 25066.01 if the service entrance conductors connect directly to the service drop or the service lateral. Okay, so in other words, you're on the supply side, right? Okay.
Yes.
And then from there, they go a little bit further than that, and they say where you have the grounding electrode taps, they're also going to be sized per table 25066. And when you're looking at that, it tells you once again it's based on what? The largest service entrance ungrounded phase conductors that are going to be serving that enclosure. Okay.
Nice.
Now, this other one will tie in, and I'm going to tell a story here about this in just a second.
David makes a good point. I think the guy who you were talking about too, Peter Grasser of Copperweld, he's the guy that's really pushing that copper clad aluminum. But dude, that's awesome. Thanks for your comments tonight, David. Appreciate you, sir. Have a good night, brother. But I just wanted to
have a good night, brother. And then
Yeah.
they talk about the tap conductor, and they tell you here that it's required here to be connected to the common grounding electrode conductor, and you can do this by exothermic welding. You could use connectors that are listed as grounding and bonding equipment, or connections to aluminum or copper bus bar. But if you're going to go to aluminum or copper bus bar, that bus bar has to be at least 1/4 inch by 2 inch, and there shall be no splice or joint to the common grounding electrode conductor. Okay. Now, let me go through a little explanation on that for just a second. Now, all that's just in D1 that they're giving requirements, but I'm going to give an example of something. I remember, God, this has been at least 25 years ago. I was doing the engineering association, the inspectors and everybody had me come out, and I was doing a code change class there. But what they really had me out there for, they needed to get their updates for the license and all that stuff. But what they really had me out there for is they had a problem out there and they didn't know how to fix it. And what the question was, they had an old historical building, and it was like 12 stories high, I think it was, or 14, something like that. And there was no steel or anything. So if you went back and you used to go back and look at the old cycles of the code and the way they actually had a step list that you would use in order to go hit the electrode. Okay. Matter of fact, at that time, there was no such thing as having a common grounding electrode conductor that went up that was continuous. Okay.
Right.
So when I was out there, they were asking me, how would you do this? I said, because they had transformers on each floor, and that's where they were stepping down. And then they, of course, needed to bond in. Well, there was no building steel. And at that time, you had the building steel, and you had your cold water pipe, and you had a ground rod. It was in that order exactly. Well, if you're 12 floors up, what good's that going to do going all the way to 12, 14 floors down to hit a cold water pipe? So they said, we're trying to figure out what we need to do. And I said, if it was me, I said, I would take, at that time, I said a 250 case mill. Now it's 3-aught. But I said, I'd take a 250 KC mill up there, and where it's coming through the floor, I'd put a strain relief on it. I said, or you could take and go through each floor, and I said, make it a continuous piece going up, but put you a plate up there. And I said, cab weld it to that plate and have the plate coming off of the building a little bit. And I said, they can drill holes and put lugs there, and then you can bond in everything over those transformers.
Nice.
And that'd be your grounding electrode conductor tap going off. I said, or you could take and go up with a bus bar. And believe it or not, actually at that time I said a 1/4 inch by 2 inch. I said, take a copper up, and I said, between each floor, I said, put a braid on it, and that allows for any shifting in the building or anything. Now that's not in the code, but that was just one of the instances I gave them at that time that they could do. Well, now if you go over and look at 250.30A6, guess what? They have that bus bar in there now. All of that started changing probably about 2 cycles after I was there, and one of the guys was actually on the code making panel 5 when that happened, and that's when they started making those changes.
Wow.
They started moving in that direction. Now,
cool.
The next thing you get into is 64D2, and this is where they talk about the individual grounding electrode conductors, and they tell you that they're required to be connected between that grounded neutral conductor and each service equipment disconnecting means and the grounding electrode system. And they tell you that those individual grounding electrode conductors are required to be sized, once again, per table 250.66, based on what again? The largest ungrounded phase conductor that's going to each one of those individual disconnecting means. So whatever size is going over, that's how you size it. And then they go into D3 and they talk about the common location. And they tell you, you can have a wireway or a wireway, auxiliary go, or any other type of acceptable enclosure on that supply side of where that disconnecting means is. And it tells you it can be used for a grounding electrode conductor that's connected to the grounded service conductors. And then, of course, you're going to size that per table 250.66 based on the largest size of the ungrounded phase service conductors that are coming to where? That common location of where the connection is going to be made. Okay? Sure. And then you get your enclosure for your grounding electrode conductors, and I don't have to get into all that. But that gives you an idea of what you're looking at this point.
So how does it come in, like when the code says you must use all available means? Can you just use one electrode, or do you have to use all available?
No. Well, if they're all available, you have to use them. And you go pick that up in 250.50. And then when you get to 250.52, that's where all your different electrodes are located in 250.52 A1 through A8. Okay. Now, the next one it gets into is talking about the enclosure for those grounding electrode conductors. And it tells you if you have a ferrous metal enclosure and it's used over the grounding electrode conductor, it's required to be electrically continuous from its origin to the grounding electrode. And it tells you it's required to be securely fastened to the grounding clamp. And the reason that is so there is no so that there is electrical continuity where it originates to that grounding electrode. Now, when you're looking at that ferrous metal enclosure and it's being used, what is it being used for also? It's for physical protection of what? The grounding electrode conductor. And that is why you want to do that. But the thing is, it also tells you there, it shall be bonded at both ends. And when you bond it, it's going to tell you the bonding jumper has to be the same size as the required grounding electrode conductor. Okay? And then the other part that's not in here is where you get into the installation to those electrodes, and it talks about your grounding electrode conductors and bonding jumpers, and this is where you have interconnecting grounding electrodes, and they tell you when you're looking at this, you got F1 through F3 that you got to comply with. So there's going to be a list down there, and they tell you that it has to be, that grounding electrode conductor has to be sized for the largest grounding electrode conductor that's required for everything to be connected to it. And then they just sort of run through there with a few little more things. But basically all they're telling you is that grounding electrode conductor shall be permitted to be installed and run to one or more grounding electrodes individually. So in other words, you could take them all individually and bring them all to connect. And then they talk about the other part, which gets into the bus bar once again, to bond everything in with your bonding jumpers from those grounding electrodes. So basically they're telling you can do exactly what I just showed you could do and how you go about the sizing and everything.
Yeah, and it just goes to show you why you don't want to use a metallic raceway for your grounding electrode conductor. Usually we just use a PVC, but I actually really want to do like a myth on that one because the support for those PVC conduits with the grounding electrode conductor in it actually increase, and a lot of people like myself, when I went and I ran one and I didn't, I just supported it like it was conduit, you know, and they called me on it and it needed to be supported at greater intervals. So it's something that the whole reason I do the myths is so that people learn and that you don't make the same mistakes as me out in the field. But like I say, I owned it and we got it corrected. It wasn't a big deal to add one support and whatever, but at least I didn't have to add chokes and everything else. So that's the whole reason why you do the PVC. Cool. So awesome, great presentation. Do you want to go to the myth or the Willie Quiz real quick?
Yep.
I haven't seen anybody pop in, but we'll see.
Okay.
I know. Every time I crack up about that, it's just so awesome. Thanks so much, Adam. Adam's the man. But you know, like I've been in like 27 countries around the world with my Spotify podcast. So it's pretty cool. All right, so welcome to the Willie Quiz. Question number 1: which NCAA school was forced to change its mascot due to a 2005 NCAA ruling on Native American imagery, but later regained permission to use it? Was it A, Florida State Seminoles? Was it B, North Dakota Fighting Sioux? Was it C, Illinois Fighting Illini? Was it D, Eastern Michigan Hurons? Or was it E, Catawba College? Good luck, everyone. Alright, looks like Daniel's popping off right away with C.
No.
Good answer, Daniel. Good answer.
I was actually, I did a class, and they actually took me to the game, and there was one of the guys, he was telling me about this, and the mascot that they had were the Fighting Sioux, and they later regained permission to use it. They were called something else, where I'm trying to remember what they were called, but it was B, the North Dakota Fighting Sioux.
Oh man, King James, I can't believe it, but you are right. That is correct. It was B.
Actually, I've actually been to their game too. That's something, isn't it?
They were like the Fighting Hawks, I want to say, or something like that.
Yeah, it was something like that. But I remember when I was up there and they took me there, they had just, I think, they had just got the name back, if I'm not mistaken. And that's how I knew about it, because the guys there that had me out there teaching, they're the ones that set it up and took me to the game. So.
Yeah, but like Florida State Seminoles never even had any problem. All right, so question number 2. What is unique about the Oregon Ducks mascot compared to other NCAA mascots? A, it has a formal licensing agreement with Walt Disney. B, it is the only live duck used as a mascot. C, the costume is the same design as Donald Duck. D, the original logo was created by Walt Disney himself. Or E, the Anaheim Ducks copied them. Good luck, everyone.
Well, I know for sure I can count 2 of them out. That's B and E. But if I remember right, Oregon used to have a live duck, if I'm not mistaken. I think, but that was like in the 60s or something. I know they don't have it now. So it all
was coming out C all night. He's just going C across the board.
I was thinking, I knew it. The design was based on Donald Duck, but I don't know if they had a formal licensing agreement with them or not. I know we didn't create the original logo, but I think it's C. Yeah, I don't think they have a formal license agreement with them, because I think when they did it, wasn't it back in the 50s or 60s that they did it?
Yeah.
Yeah. Okay. That sounds like Donald Duck. Yeah. Okay. Because I don't think they did license agreement back then. So yeah, I'll go with C.
All right. So if you and Daniel were gonna pick another answer that was not C, what would it be?
Oh, so it ain't C. Well, I guess. It had to be A or E, or D, I mean. I guess I'd have to go with D.
All right, and Daniel gets the second answer right. They actually have a formal licensing agreement with Walt Disney. At first, you're right, they didn't have it, but it was later. Actually, they did get a formal licensing agreement later, after the 50s and 60s. So,
but wasn't the costume based on the design of Donald Duck?
Yeah, and they actually had to go get a formal licensing agreement from Walt Disney.
Okay, well, that's why I didn't think a formal licensing agreement, because back then they didn't even have them.
Yeah, so looks like Daniel's second answers are better than your second answers.
Yeah, apparently so. He still missed 2. You don't get the second one.
It's all good. All right. Question number 3. Which NCAA team's mascot, Big Red, is known for being a large amorphous blob with no clear animal or human features? Is it A, Alabama Crimson Tide? Is it B, Harvard Crimson? Is it C, Stanford Cardinal? Is it D, Southern Illinois, Seleucus,
Uh-huh.
Seleucus, or E, Western Kentucky Hilltoppers? Good luck, everyone.
Well, I'm saying thing about it. I've automatically ruled out the first three. I know Stanford is a tree, Harvard. I know they're not, and I know Alabama isn't. So the next two, I'm unsure about. This is interesting. I'm going to think about this for a second. I think, if I'm not mistaken, because I've seen that red blob on TV, but I don't think I've ever seen Southern Illinois. I've seen Western Kentucky on because of basketball and stuff, and I know they got somebody has that. It's like he has a costume, but it just looks like a red blob, you know. And well, you got the amorphous blob. So yeah, I think I'd have to go with D.
All right, looks like you are going to copy
He
Daniel
went E
with
too.
the correct answer of E, the Western Kentucky Hilltoppers. Good job. Looks like we have a pretty spirited contest tonight so far.
Yeah.
So here we go.
All right.
All right. Which school's original logo featured a cartoonish devil before transitioning to a more modern and fierce-looking version? Was it A, the Duke Blue Devils? Was it B, the Arizona State Sun Devils? Was it C, the Wake Forest Demon Deacons? Was it D, the Rutgers Scarlet Knights? Or was it E, the Mississippi Valley Delta Devils? Good luck, everyone.
Well, my first thought is B, and I'll tell you why. I remember they used to have the devil on their thing. Now they just have the pitchfork that's going up, and it has a fierce looking little pitchfork. And I think it looks freaking awesome. I love Arizona State's helmet, so I'm gonna go with B just because I like their helmets and that new pitchfork they have.
Well, I'm really glad that you were deciding to copy Daniel because you are correct. It was actually B. So,
I know I had that answer out before he said anything because I said it right when it stopped.
We'll have to timestamp that one. It
Oh,
looks like
I'm going to win tonight. I know this one.
Yeah. All right. This one, it was an easy quiz. So, what is the only Power 5 conference school that has a tree as its primary mascot? Is it A, Oregon State Beavers, B, Stanford Cardinal, C, Minnesota Golden Gophers? I didn't put that in there on purpose. D, Washington State Cougars, or E, the South Carolina Gamecocks? Good luck, everyone.
Oh, let's
All right,
see.
Daniel had to answer out way before you, so.
This is a hard one. God, what will I choose? Oh, wow. Stanford has a Cardinal. I'll go with Stanford.
Yeah, so you are correct, and it looks like King James takes the freaking win this week.
Finally, I got 4 right, and there was no tie or anything.
Yep. I did get a tiebreaker just in case, but as an
Oh, well,
interesting
no.
note,
What is the tiebreaker question? I want to know. See if we can guess it.
so I was just gonna like hold back on that until next
Okay.
week, but
Okay. All right.
there was no tie this week, so I don't want Daniel getting all like fired up that like we're in collusion with our tiebreakers. So
Well, they got it the last 2 times, or last time.
all right,
I got the one before.
all right. What is the name of Colorado's Buffalo mascot?
Oh, I do know this one. Starts with Ralphie.
I didn't see Daniel's answer, but Ralphie is correct.
Yeah.
That was just one I had off the top of my head. But I wondered if you knew it.
Hey, I like Colorado. I love going to Colorado. I mean,
Yeah.
I love the state of Colorado. So when I was growing up, that's where we went on vacation a lot of times. There's a place up there we used to go to. I don't know if you know it. It's called Monument Lake. You know where
Yeah.
that is? We used to go fishing up there, and they had cabins and stuff, and they had little John boats that we would go out there and go fishing in and stuff. I was probably like 12 years old, and we were fishing out there, and then we used to go up through Pagosa Springs, up through there, and Colorado Springs. I mean, I've been all over Colorado. We took the train ride from Silverton to Durango to Silverton. We took train ride.
Silverthorne. Was it Silverthorne?
Silverton to
Okay.
Durango. I've done that like 3 times. And
Was that narrow gauge? The narrow gauge railroad?
I think so.
Okay.
It was
Yeah, I
all
think I
fun.
do.
Beautiful running down the side mountain there. It was a beautiful place. I mean,
I think that's the highest elevation train in the world.
oh, is it? Yeah, well,
Yeah.
I've been on it twice, and I remember Dad got a little lightheaded, and we were coming down. We were there in Colorado Springs, and we went. I forget the name of the area. It's not far from the Garden of the Gods, and you can go up and stuff. And I stayed up in front of him, keeping him right here, as we got down, because he was a little dizzy, but we got him down there thing. And he said, shit, I ain't used to this elevation anymore. Didn't bother me, but it was affecting him. So,
Yeah.
all right. You ready for Tool of the
that's
Week,
cool.
brother?
Let's do it.
All right.
It's time for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
So this week's tool review is actually a tool that is not actually released yet, but it's been highly anticipated. That's why I kind of wanted to do a review on it. I'll tell you what, I actually want to get one of these. This is like a 238 piece Milwuakee pack out tool set. It comes loaded. So it's a pack out that you could buy, and it is already loaded with tools. So to me, this is awesome. Like, I want this like so bad. When I saw it, I was like, oh yeah, that's it. Because you don't have to do anything. It has all those deep sockets in there. Like, I mean, just the amount of deep sockets in there I thought was amazing. Metric and standard. It has the front rollout tool drawers. So there's actually 2 parts to this Milwuakee pack out that they have that's coming out. They have the front rollout tools for your bottom, and then they have the front rollout tools for the top, and then you have the wheel section. So all that is all new for the Milwuakee pack out, and like I say, that's just gonna like revolutionize our tools out in the industry. Like I say, when I saw this is something I'm like, this is like a must-have. Like, I'm not a real big fan of the red stuff, as everyone knows, but this is like a breakthrough that pretty much everyone's gonna jump on. I don't know the exact cost because it's not actually released yet, but just to have those, this is kind of a new design with the rollout drawers like that with the pack out design, but to have that fully loaded with tools, with sockets and socket wrenches and everything ready to go, I think it's just an amazing tool release. I give props to Milwuakee on this one because everyone's going to be rushing out and buying this. This is going to be one of the best tool releases that you'll probably see Milwuakee have probably ever, just because it's so easy to just go pick up a fully loaded toolbox and just throw a lock on it, slap it on your existing pack out with wheels and everything, and you're good to go. So
Cool.
honestly, I really like that. I think it's a really good tool. So
All right.
that's my review is big thumbs up to Milwuakee. So let's see if I get you on the question again 2 weeks in a row.
All right, let's see what you got. Let's see. He can start him while it's right there, no more. Oh, I remember this one. It's like 424, 36, I think, or 35, something like that, but it's 4 feet.
Ding, ding, ding. You are correct.
I knew that
was
was
the correct answer for all the people out there.
I know it's right on that.
That was out of a Stall Cup's code change book, and I didn't get him for a second week in a row, but it was cool.
You get me about
Cool to
once
try.
every 100 questions.
Something like that. 90, 80, 90. Dude, don't be getting the math off, man. We already went through this, man. I'm gonna get all this hate mail again. Like, I can't say 30, 50, whatever, you know.
All right, let's finish her off. We got Wall of Shame.
Okay.
Then we're done for the night.
Shame. 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 Shame.
Big shout out. We still have 4 people over there on the Rumble side. So
awesome.
Big shout out to people over there on Rumble.
Yeah, thank you.
This one, dude, this is just like a waste of time. Like, I mean, it's decent. It looks decent, but like, I don't know, man. I don't know why you would do this. Like, to me personally, just come straight out the top. Like, I don't understand all this. Like,
I don't either.
I mean, you could just
looks
come straight
good.
out the top. Yeah, I mean, it's decent, but you could double stack those. And I don't know. I think they were trying to make some pretty artwork, but I don't know. To me, I almost would come out the wire way and come down, do a short 90 in the top of the light, like without doing those weird swoop things.
Yeah, I mean, he did this. That's some good pipe bending right there.
Yeah.
That's some pretty good talent right there. I'm gonna give him props, whoever did it. I think. I mean, I wouldn't have done it that way, but I mean, it looks good. I mean, he's got some swoops coming down, Ben. I mean, whoever did it, they knew what they were doing.
The whole reason why I wanted to do it for Wall of Shame was because it got posted in the Wall of Shame, and a lot of people, if the pipework's not exactly perfect, then they're going to have a bunch of flaws in it. So
I tell you, I have no problem with that. I think it looks pretty damn good myself.
yeah, it's all right. I mean, it's not perfect. The spacing's a little off, but stuff like that is like kind of what helps us get to that next level when you see
Sure.
that kind of work, and then you do your own work, and you're like, oh, I'm not gonna go off by a half inch again, or whatever. But
He put some time into that. It wasn't easy doing all that.
it was definitely an art project, not a practicality contest. So
Yeah, I think so too.
that's why we ran it for a Wall of Shame. But appreciate gentleman who posted that on the Wall of Shame. And dude, we're almost to 250,000 people on there now. Like it's crazy.
Just
We're
keeps
like
growing.
225,000. So
It's freaking awesome.
really awesome. Thanks so much, everyone that participated. Myth of the Week, everyone that participates to help us bring this content. Thanks so much, King James, for putting up with me. Throwing you under the bus sometimes. Not really trying to, but it's just you never know. I sometimes get some information, and I'm not saying where it came from, but we have to do the customary quiz shot for Adam. Appreciate Adam every time he's here. That's badass.
Amen. All right, well, let's wrap it up. My son's called me, so I got to call him, and he called like 20 minutes ago. I said, I'll call you after the podcast. So he's like, okay. So I'm not sure what he wants, but I may check in with him.
Right.
So. All right.
Well, it looks like we cracked off 2 hours for everyone. So
Sure did.
really appreciate everyone joining. And as always, remember, make every day an easy day.
Amen. Everybody have a good week, and we'll see you next Thursday.